Doing a little 4-2, a little more complicated. It is or statements and and statements, which is called compound inequalities. We're going to start with some real basic ones, and you got to trust in me, these are going to get harder, so follow the leader here. Don't be a cheater, follow the leader. Up in the box, or statements is the union of the two graphs that we have. So what I do is I created my own system to where we're going to graph each one of these inequalities separately as what I call helper graphs. The reason why I call them helper graphs is they will help us get to the right answer. So they do not go on the number line. You see this first one right here says b greater than 2. What kind of dot? Open dot or closed dot? So let's go to 2, but way up here, put you an open dot at 2. Like it's not going to be on the number line. It's going to be up above it. And greater than 2, how do you feel about that dude right there? Is that like how you would draw it if it was on the number line? But this is not on the number line because this is going to help us get to our answer. But then they have a magic word, which is or, and we have discussed that or means we're going to do a union of some things. I need to unite it with the other graph, b less than or equal to negative 3. What kind of dot? Closed dot. So I'm going to go right here above the number line, put a closed dot at negative 3, and go like this. And since this is an or statement, I need to unite these graphs together. I don't care if you're on the blue graph. I don't care if you're on the red graph. You are in this answer. Just like if you are right-handed, you got the prize. If you are wearing jeans, you are getting the prize. Even if you had both, you are getting the prize. Are you with me on that? So the union means our final answer will go down to the number line. The entire blue thing comes down. Doesn't the blue thing look like this, even though I'm making him green? Since he's on the number line now, let's make him fat. And the entire red thing comes down. So to win this prize, you had to pick a number that was less than or equal to negative 3 or bigger than 2. And would you believe that that green graph up there represents all possible answers that you could do? Anything that is less than or equal to negative 3 is on the green graph. Anything that is bigger than 2. Or means union. Let's try that again with helper graphs. First guy, I will graph him as a helper graph. I'm going to make him red. So a closed dot at negative 4, up above. Less than, going to the left. Then the second one, y greater than 0. So I go to 0, put an open dot, and he's going to go this way. And you have to really buy into this. What's the word? Is it and or is it or? This one is or, so we are going to unite these together, meaning the whole red one comes down and the whole blue one comes down, and we get an answer that looks like this in green, which is in pieces, which is called a disjointed graph. Means it's got a couple pieces to it. We'll learn more about that another day. So one more of these simple boys. Notice we didn't have to solve for y at all. They just literally straight up told us that these inequalities, like I don't have to get x all by itself in this one. It's just we're starting out easy to get rocking with this. So first one, x less than or equal to negative 1. So I'm going to make him a helper graph. And then x greater than 2, helper graph. And the word is still or, so or means we're going to unite these together. And they start looking pretty basic. People get into a little bad habit. They go, oh, I see what's going on here. All or graphs are going to point different directions. That is not the case. These are normals, though, right? These are what I call, if you notice here, normal or statements will look like that. But some of them are strange. Are you with me on that? So I got some strange ones down here. We're going to graph each one of these as a helper graph. So first thing I'm going to do is q greater than or equal to 1. What kind of dot? Closed dot. Boom. Helper graph up here. You feel good with that first guy? Then the second guy, I'll graph in blue, another closed dot. And then less than. And now we start tricking ourselves, because those totally overlap each other. Are you with? Before they did not overlap, I got to ask you what the word is. Is the word and, or is the word or? Or means the union of all of these. I'm going to do it in 2 phases. You just watch, and then I'll let you do it. But I'm all going to do it in the color green. I've got to bring the entire red thing down. Just watch. There's the red one, right? And then I got to bring the entire blue thing down, which is right there. And if you just look at the green thing as a whole, what happened? It's everything. Are you with me on that? So that's what you bring down to the number line. You bring it all down to Chinatown. You can draw it now, nice and fat. And what we got to do is answer this question. They'll be like, hey, what values of Q work? It's all of them, dude. So, like, how do you type that in? Well, we're going to do it the fancy schmancy way because this is the way the ACT does it. Welcome to set notation. I think we're fancy with these set brackets. Remember that from like last chapter, the set bracket. What letter are they using? X, Y, W, Q. What are they using? So we're going to say the set of all Q's. And then put this up and down guy right here. Straight up and down, even a little taller than the set bracket. You would say that out loud as such that. It's the set of all Q's such that. Would you believe this is like all real numbers in the world, right? So we're going to say Q is this. Do you remember this symbol? Is an element of, right? So make like the letter C and put a staff in it. Can you remember from way back in chapter 1, there is a symbol for all real numbers. It's one of those double bar guys. Double bar what? Double bar Z is integers. Double bar what is for reals? Real. Double bar R. Good. Double bar R. So it's the set of all Q such that Q is an element of the reals. You might put a little note to yourself how we said this out loud. This is said such that. That's straight up and down, guys. Said such that. And the reason why I like to write it this way is because that's how the ACT lists them. Multiple choice. If you can't read it, you can't answer it. Do you know what I'm saying? So that's how it's written on the ACT. So let's try that again. That was a weird one, right? D is greater than 0. So I'm going to use different colors. So I'm going to go red for that guy. So open dot. Or D is greater than 2. Open dot. Whoa. They are like totally both going the same direction. The question is, do I want the union of those two graphs or do I want the intersection? Or means union, right? This is an or statement, so we will unite those together. So again, you can watch this. I'm going to bring the whole blue one down. Check me out, right? But hold on, I got to bring the whole red one down as well. And my question is, when I bring that red one down, does this part of it fill in that open dot? Yes or no? Does it fill that open dot in? It totally does. Totally, totally does. So if I said, you've got to pick a number that's bigger than 0 or bigger than 2. Are you with me on that? What numbers work? Here's what you do. You ignore the helper graphs. You can't erase them, but you ignore them. And those are the numbers that work. What numbers work? Any number that I pick that is what? Greater than 0. That is the answer to this question. That's D greater than 0. That's how you'll type it in on homework. They'll say, please write it as a single inequality. Because even though they gave you two choices, like, hey, D's got to be bigger than 0 or D's got to be bigger than 2, the whole bigger than 2 crap got washed out because it's like any number you pick bigger than 0 is going to satisfy this. If you are right-handed or you are wearing jeans, you got extra credit. Well, anybody that was right-handed, I think everyone raised their hand. It was like totally pointless for us to even ask the jeans question in that scenario. Are you with me on that? So if you're bigger than 0 or you're bigger than 2, those are weird. What helps? Helper graphs. Helper graphs will save the day, right? Make you some helper graphs. So let's do some and statements. Guess what and means? It sure isn't the union, it is the intersection. So we'll start out with some basics. Let's graph him. B is greater than -1, so open dot, doot, 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 doot. And then right underneath that guy, instead of side by side, like ands are a little more challenging, so I did my helper graph right there. The next one I'm going to do is underneath him, close dot at 3, and then to the left, I care about the intersection of these two graphs, where I have red on top of blue. Are you with me on that? Where they intersect. How do you feel about that is in this zone right here? Isn't that where they are on top of each other? That's what gets brought down to the number line. So it will be an open dot here. Let me use green. So this open dot comes down. This is a closed dot. He comes down. Are you with me on that? And then we fill it in the middle. Any number that I pick in that green zone satisfies. You got to give me a number that's bigger than -1 and less than or equal to 3. So how about 1? Does 1 bigger than -1? Yes. Is 1 less than or equal to 3? Do you see how it satisfies both of them? You got to be right-handed and have genes on to get that scenario going. You have to make both statements true. So how the heck do you type that in? And statements are weird. Please trust me on this. What letter? B goes in the middle. Sometimes you got to write it down on paper first because it's weird to just type in from left to right. B goes in the middle. These arrows always point to the left. Those are inequality symbols, but I make them like arrowheads. They're always pointing to the left. Then I pick the smaller boundary. Isn't -1 the smaller boundary in that case? And 3 is the bigger boundary in that case. You see the two numbers on our number line. All I'm doing is reading what our final graph was. I don't care about the helper graphs. I care about the final graph. You see that -1 was the smaller number and 3 was the bigger number. The only thing I got left is to go back and find equal to bars. Does -1 get an equal to bar? Is he an open dot or a closed dot? Open dot. And then what do you think about here? Does he get an equal to bar? Yes. That's weird. And to read that out loud, math is not read left to right. Math is always read from the variable. So this says B is greater than -1 and B is less than or equal to 3. It's just weird. And statements are weirdos. So let's try again. We'll figure it out with helper graphs. So x is greater than -3. We will use a red one. Open dot to the right. Second one, 4 is the critical value. He is a closed dot, and we shall go less than that as well. And I'm just going to keep stressing it because they're all mixed up on your homework. What's the word? And or? And means intersection, where these intersect. If you like to put a little squiggle on your paper, you're like, yeah, I want those. I want to know where the red one and the green one were right on top of each other. You're welcome to put that little squiggle. The intersection comes down to the number line. There's an open dot at -3. There's a closed dot at 4. And everything in between there satisfies both of them. So to write that as a final answer, we put that compound inequality where the letter is in the middle. And if you always keep your your numbers from smallest to largest, these symbols will always point to the left. Like it always happens. But the small number has to be here, and the big number has to be there for that to work. And then you go put your equal to bars where you need them to. Sound cool with that? Do you notice that they just put it in that form already on number 8? So sweet. If it's in this form, and the small number's on the left, the bigger number's on the right, and the arrowheads are pointing to the left, it's going to look like this, where like they met in the middle. So I don't need any helper graphs. I'm just going to go down and put me a dot at -5. What kind of dot do I need at -5? Closed dot, bada boom. I'm going to put a dot at 2. What kind of dot do I need? And ands will go in the middle if they are normal, which these are all normal and statements. They meet in the middle. Cool? But not every and statement does that. Some of them are weird boys. So let's see some weird boys. Let's graph each one separately. Holy crap, I don't even like that. You know why I don't like that? Because the D is on the wrong side. So I'm going to switch that around. I want the D to be on the left and the -3 to be on the right. And then guess what that symbol has to do? Who's he pointing at in the OG? Who's he pointing at? Is he pointing at the -3 or is he pointing at the D? Pointing at the -3. He's still got to be pointing at the -3 to make it equivalent. So doesn't that say D greater than -3 in that case? So we'll graph him as a helper graph. D less than 2. That's an and statement, so find the intersection. Bring that down to Chinatown, which I call the number line. So open dot there, open dot there, just like that, and see if you can write it as a compound inequality. D goes in the middle. Which way do the symbols point every time? To the left. Smaller number on the left, bigger number on the right. No bars needed because they're both open dots. What made him strange? They typed that backwards for me, and I needed to switch it around. Otherwise, he still turned out pretty normal. Are we okay with that? Now, let's try this one. D greater than 2. D less than -1. Decide what the answer should look like. Is this purple thing our answer? Thoughts? What's the word? And or? And, which is the intersection of those. Is that purple thing where they intersect, where I got blue on top of green? Where do those intersect? Where do I have blue on top of green? I do not. I totally do not, right? You know? So what comes down to the number line? Well, on homework, they'll tell you what to do. Sometimes they'll say just leave it blank, right? On paper, I need you to do this. Next to the number line, put a circle with a slash through it. The circle with the slash means there's nothing there. It is empty in that case. Empty set. What do you type? For empty set, you can put the set that's empty if you wanted to, or you could do this if you wanted to. On homework, they might say put DNE. I do not want you to write DNE on paper. Rock on. That was just the lead up to prepare you for and or statements. Now we have to do them for real. So here's what I think we'll do. First, we'll find the word. What word is it? And or? What does that mean? Union or intersection? Watch this. This is going to help your brain. I'm going to put a union symbol right above that. I need the union of these two graphs. Let's take number 11 here. Let's solve him for x. So what's my first move right here? Subtract 4. Does the symbol switch? Nope. And then divide by 2. Does the symbol switch? No. Then solve the other guy. Oh no. Bring your x's to the left. Bring your x's to the left. So negative x. Realize if you should switch the symbol or not. I do not want a negative x all by itself, so I get rid of the negative by dividing both sides by a -1, and doesn't that switch the symbol as well? Now we've got extra trouble because we have to graph both of those. I have no numbers on my number line, so we got to make them both fit on there. Who's the smaller one of them? I'm going to put him as far left as possible. He's the small guy. Can I make it to 4 counting by ones, yes or no? Because like if that other number was 16, would you believe I can't make it, you know? So it's like I can make it counting by 1, so we'll put them all. I know last time we kind of skipped some. Sometimes it's nicer to just like put them all. Graph both of them as helper graphs. Helper graph. And as we get more comfortable with this, you have the answer written down already of what you should do with those two graphs. Do you want the union of them, or do you want the intersection of them? We wrote it down already. It's the union. So the entire purple one comes down, and the entire green one comes down. And to answer the question, we only care about that graph. Everything else should get ignored. That is our answer. So how do we write it? From left to right, what does this one say? X is what to 1? Less than or greater than? I know it's got an equal to bar, but less than or greater than? Less than or equal to? We'd have to type a word in there. Guess what word it was? Was it and or was it or? Or x greater than or equal to 4. That is what you will have to type in to homework. You'll have to use this inequality or that inequality. Groovy? Let's try that again. What's the magic word though? And or? What does it mean? Boom, intersection. Right? That's an intersection. Solve both of them for y. Check them with mine. And then find your smaller number. And can I make it to 3, starting from -1, counting by ones? So, yeah, 0, 1, 2, 3, 4, 5, 6, 7. Probably could have even skipped some. If you can skip every other one and still make it, that's fine. Right? Just make sure you can make it. X less than 3, excuse me, y less than 3. Y greater than or equal to -1. And you just got to know what the word was, and or. This was an and, which means we want the intersection of those two bad boys. So bring down to Chinatown where they were on top of each other. And then you've got to write your final answer. When it's an and statement, we will write it as the compound inequality. The letter goes in the middle, smaller number on the left, bigger number on the right. Choose your symbols. They always point to the left. Are you cool with everything that we did work for was a setup to get that graph? The graph tells you what the answer is. You just got to read it. Cool. Let's see how few of these we have to do. Let's try, let's check out 13. That's different. Is that an and statement or an or statement? What do you think? It's an and. Like, we haven't talked about it, but or statements cannot be written like that, where that compound inequality, those are always and statements. Here's my question. Is P all by itself on the inside? Nope. So I'm going to teach you how to cheat this. If there were X's or P's or whatever on the outside, we'd have to do this a different way. That's not the case. I would like to get that P all by itself. There is a -5 in there. How can you get rid of that -5? We're going to add 5. Most people say to both sides. There's actually 3 places. You got to add 5 to all 3 places. So we'll do it here, we'll do it here, and we'll do it here. Are you cool that there are 3 zones? There is a left, there is a right, and there is a middle, right? So we got to add 5 to all 3 places. So this would become a 2. The symbol does not switch because we did not multiply or divide by a negative. The P is in the middle, and then the symbol comes down, and that is a 7. Are we rocking and rolling with that? So now you just put those 2 points on your number line. Start with 2 way over yonder, and let's get up to 7. Finish him out. And then you decide what dots you need. The 2, whatever bar is closest to him, that is does have an equal to bar. 7 does not, so he is an open dot, and those always look like this. When we get into some advanced, serious stuff, your junior year, they'll put some P's out there, and it's a whole nother story. Like, you got to do a different work. They'll teach you how to deal with that when you get there. Cool. All right, let's try. There's just one more left, correct? No. There's 3 more? All right, let me see which ones we got here. There's some weirdos. Let's just do 14 and call it a day. Huh? Get 14 done, work with the neighbor, realize if it's a union or an intersection before you get started. I can tell a lot of people are a little stuck on this second part. Are we cool with the first part being y less than 5? I want to move this over here, so I'm going to do that. How do I move that over there? Subtract 2y, right? So what's 1y? Take away 2y. Negative y. The -3 comes down. The symbol comes down. People get so scared. They're like, there's nothing left over there. I know there's nothing left over there. What number should go there when nothing is over there? We'll put a 0 there. Cool? That's a tricky one, right? When you move everything over there, you still have to have something. So that's a 0. And then I will add 3. And then I'll get rid of that negative by dividing both sides by a -1. And ooh, we might cut it close here to go from -3 to 5. See if we can make it. -3, -2, -1, 0, 1, 2, 3, 4, 5. Saved it. What if I had to go to 6? I'll let you extend it out 1 more tick mark. But if you got to do more than 1 tick mark, I need you to count by something else. Like maybe you need to count by 2s. Maybe you need to count by 4s. You got to count by 5s. We feel good with these so far? Cool. Ew. They both went the same way. What's the word? And or. Which means union. Bring it all down. The entire red thing, the entire blue thing. So all of it. And you don't need like a dot there. You know, I know there's a closed dot there, but it's just understood that it's when you draw the thing fat, it's still there. I would like to do one more made up one because we haven't seen it yet, and I know you'll see it on the homework. But are we okay with that? Let's graph this. So scratch this out. Let's graph, just go 0, 1, 2, 3, 4, 5, 6, 7, 8. And let's graph x less than 4 and x less than or equal to 8. So I saved this algebra. We don't need to do the algebra because I just got x by itself both times, but let's do helper graphs. Graph each one as a helper graph. And see if you can get a final graph without me. Work together. What's your final graph look like? That purple thing is the union of those two graphs. I do not want the union of those two graphs. What do I want? I would like the intersection. So it's where the blue one and the green one are on top of each other. And with an orange highlighter, that's here. Are you cool with that? That's like right there. So only that comes down. The real question is, what kind of dot is it? Open dot or closed dot? It's got to be open because this blue one doesn't have 4 with it and the green one does. It's got to be in both. So that's an open dot going this way. That is the intersection of those, written as one inequality for like a final answer. That's x less than 4. That's like how you'd type that in. So they can be tricky, and we will find that out when we start our homework right now. Let me know if you have questions.